This is presentation about report of noble gases and their chemical reactions. The report focuses two noble gases. The gases are xenon and krypton. The report offers insights into the chemistry of noble gases and their compounds. There is talking about how noble gases studied and why it takes so long before the chemistry researchers showed interest about the compounds of noble gases. While moving on, this study led researchers to found general formula for noble gas hydrates. Every noble gas has stable structure, which makes them very inert and unreactive compounds. Helium has a doublet, and all other noble gas have an octet. The unreactivity is because the electrons are occupying atomic orbitals with paired electrons. Because noble gases are not reactive compounds, they have only little interest to study, but the year 1962 changed it when the chemistry researchers find the first compound, xenon hexafluoroplatinate. That was the start about the study of noble gas compounds. The study of noble gas compounds has led us to find two types of noble gas compounds. The first type is insertion compounds, and the other type is complex type compounds. In this part, I tell general information about xenon as an element and how it forms compounds. The most important thing xenon forming compounds is that the valence states can be 2 to 8. Today, the most known xenon compounds are the binary fluorides of xenon. The binary fluorides are xenon difluoride, xenon tetrafluoride, xenon hexafluoride. This report gives information more detailed about those types of compounds, and I will present those one by one. Xenon difluoride can be forming with many various methods. Those are circulation, photochemical synthesis, nickel system, and electronic discharge. Important thing is that the forming xenon difluoride needs equimolar amounts of xenon and fluorine, and the pressure must be 30 atm. Xenon tetrafluoride was the first binary xenon fluoride that managed to form. The method was heating, but the other methods that can be used are electric discharge method, and the reaction with hydrogen can also produce xenon tetrafluoride. Xenon tetrafluoride has monoclinic system and consists planar square symmetric molecules. Xenon hexafluoride is produced by pressurizing xenon difluoride in high pressure nickel tank. This reaction needs high pressure and temperature to changing xenon difluoride to xenon hexafluoride. However, need to say that xenon hexafluoride structure is not totally successfully determined yet, and they need to study more to find out the structure completely. Second noble gas, krypton. Krypton is not forming compounds as easily as xenon, but it's only noble gas that produces chemical compounds in macroscopic quantities. Report focus on krypton fluorides as simplest compounds formed by krypton. Krypton fluorides. Krypton difluoride can work as an oxidation fluorination agent. The forming krypton fluorides is endothermic reaction. That means it needs much of energy outside about the system that krypton fluorides can be formed. Other krypton compounds. The krypton's ability to form compounds can be explained with its lower electronegative substance. The types krypton can be formed is krypton, fluorine, cation, organic, and forming compound with organic nitrogen, and oxidizing properties of krypton fluorine cation. Conclusions. This report offers information obtained about noble gas compounds and their stability. The noble gas compounds are used about the storage noble gasing. The most used method is the fluorination noble gases. Ongoing research and potential gives potential to further discoveries in this field, and the other noble gas compounds that we don't know yet can be found. References. These are the science articles that has been used making this report. And this is where I end my presentation.